Hi, I'm going to do section 1-7, the bamboozle section, problem number 12 real quick for Maisie, but anybody else who wants to pay attention to this. So this is section 1-7 and it is problem number 12. And I believe the problem is to prove, I think essentially what they want you to do is prove that 1 over 1 over x times x equals 1. Is that right? Is that problem number 12? Let me make sure. 1 over 1 equals x. 1 over 1 over x equals x. Yeah, that's not what we're trying to prove here. Let's try this again. Let's get this correct. 1 over 1 over x equals x. There we go. Finally got the problem right. Helps to do that. Okay, so we'll start over. We're going to start with this for our first step, I think. So that's what we're going to prove. I do think we have to make a condition here that x is not equal to 0. Because if x is 0, you would have, 1 divided by 0 right here. X can't be 0 here. So that's just going to have to be a stipulation throughout the whole proof. X cannot be 0. All right, well, okay, let's start with this. 1 over 1 over x, okay, times 1 over x equals 1. Do you see why? 1 over 1 over x times 1 over x equals 1. I mean, think about this. I mean, this is just going to be like let's pretend right now that this is a tree. Do you get what we're doing here? 1 over a tree, whoops, times, and see 1 over x is the tree, so we'll make all of this the tree right here. 1 over the tree times the tree equals 1. 1 over a times a equals 1. That's the multiplicative inverse. 1 over anything times something equals 1. So it doesn't matter. I guess I want you to see, let me get rid of all this purple here. I want you to see that it's okay. I've got 1 over x in the denominator, but that's what I'm multiplying by, the full denominator there, and so I get 1. So this is just the multiplicative inverse. All right, well, but this also is the multiplicative inverse. 1 over x times x equals 1. That's also a multiplicative inverse, right? A number, here's the number, times its reciprocal is equal to 1. That's what we have there, right? Just like it's what we have up here in step number 1. Here's the number, and here's the reciprocal of the number. 1 over x, I mean, the number happens to be a fraction. Just like the, I just want to say it one more time, okay, the 1/2, the reciprocal of 1/2 can be 1 over 1/2, like that. Now 1 over 1/2 happens to be 2 because 1 divided by 1/2 is 1 times 2 over 1, and so it's going to equal 2. So the reciprocal of 1/2 is 2. But anyway, you could write it like that. All right, so hopefully all of this is making sense so far. So all I've done is I've used the multiplicative inverse twice here. But now, look what I have. Here, let me even pick a different color here just to emphasize. Look, I have all of this right here is equal to 1, and all of this right here is equal to 1. So I can just set them both equal to each other, right? So 1 over 1 over x times 1 over x has to equal 1 over x times x. And then number 4, again, because we know that x is not equal to 0, this is a condition. X cannot be 0. Because it cannot be 0, then the converse of the multiplication property of equality can be true. If x is not 0, I can divide both sides by the same thing. So essentially what I'm going to do here, is what we do all the time. We're going to just divide both sides of this equation by 1 over x, And then there we go. When we do that, we get 1. This is it right here. 1 over x equals x. That's it. Oh, I forgot to say the reason right here. This would be, what would we call this? You know, here, if well, I guess I could call it transit. I'm going to call this transitivity. The reason why is because, you know, it's something like this, right? If A equals B, right, and B equals C, then A equals C. I mean, that's really what happened here. Here we have, you know, all of this equals B, and then all of this also equals B, and so A has to equal C. So it's really just a form of transitivity there. All right, and then 1 over x, like this, has to equal x, because here all we did was to divide. This is we could call this the multiplication property of equality. It's because of the multiplication property of equality. It's the converse of the multiplication property of equality, which is true because x is not equal to 0. All right, well, hopefully that helps you understand it just a little bit better, okay? Tried to overkill on the explanations, but hopefully that helps. All right, see you in class. Bye.